form of this data. And then finally, if we can find that structure, then we can generalize. We can go from observed data to data we haven't seen yet, whether that data is some other part of the network, for instance, or maybe other networks of the same kind, or going from small scale to large scale in the sense of coarse graining. You might say that I want to represent the entire United States social network by modeling it as these sort of groups. Like there's the Northeast, and they tend to interact with themselves, and to some degree to the Midwest, maybe to the South, and so on. And then finally, thinking about going from past observed to future unobserved. All of these questions, to answer them, you have to understand something about what the structure is in the network. OK. So a lot of times when we're past sort of big pile of data, we don't really know what kind of structure is there. So we have to learn what it is. And to do that, we need some data analysis technique, some way to model this data. So a principled approach, this is the approach that I take along with a number of other people in the field, is to use generative models. These are probabilistic models that let you quantify uncertainty about whether or not two vertices should or should not be linked, given what you can understand about the structure. So essentially, it works like this. We're going to define a parametric distribution over networks. So all graphs and networks are essentially interchangeable. The words, there's not a distinction between the two words. So we're going to define some probability distribution over all of graph space. We want to structure that distribution so that more of the density falls in the graphs that look like the ones we see in the real world. So we define that as the probability of some graph G given theta, where theta is really just a shorthand for representing that structure. So there are two different things you can do with this kind of model once you've started down this path. The first is you can generate data, which is actually really useful. So if I specify what the structure is for a particular kind of graph, then I can draw instances out of this distribution, and I can study them or use them for other kinds of things. Or more commonly, if we're past some data, some graph G, we want to understand what structure exists in that.